All right, let's talk about a new technique that is promising to absolutely shatter the speed limits for large language models. It's called DFlash, and it might just change how fast we can get answers from our favorite AIs. Let's dive in. So, get a load of this number, 6.17 times faster. That is the headline claim, but here's the kicker. The part that makes this so incredible, it's completely lossless. We're talking a massive speedup with zero, and I mean zero, loss in quality. The AI's output is exactly the same as before, just way, way faster. So you have to be asking, right, how on earth is that possible? How did the folks behind DFlash crack a problem that has been the fundamental speed limit for AI for years? Let's peel back the layers and see how they did it. Okay, to really get what makes DFlash so special, we first have to understand the problem it's trying to solve. Why are these huge AI models so, well, fundamentally slow to begin with?
It all comes down to a process called autoregressive decoding. The best way to think about it is to imagine a storyteller who has to write a book one single word at a time. And before they can write that new word, they have to go all the way back to page 1 and reread the entire story up to that point. It works for sure, but man, is it slow.
So this one word at a time process is, by its very nature, sequential. You literally can't generate word number 10 until you've figured out word number 9. And this lack of parallelism means that even our most powerful, most beastly GPUs just hit a wall. It's why long, complex AI answers can feel like they take forever. Now, researchers have been banging their heads against this wall for a while, and before DFlash came along, the best trick they had up their sleeve was something called speculative decoding. It was a really clever idea, but yeah, it had a fatal flaw.
The concept is pretty neat. You have a small, fast assistant model that just blurts out a quick guess of what the next few words will be. Then the big, smart editor model comes in and checks that entire guess all at once. It accepts everything that's right, fixes the first mistake, and then the whole cycle starts over.
But here's the hidden problem, the thing that held it back. That little assistant model, the drafter, it was still using that same old slow one-word-at-a-time method to write its guess. And because of that, the real-world speedup was capped at maybe 2-3 times faster. An improvement, sure, but not exactly a revolution.
And that is where DFlash comes in. It doesn't just tweak the old method.
No, it pretty much throws out the old playbook and starts fresh. So let's unveil the two-part secret sauce that makes this whole thing work. The entire thing is built on this one, super simple but profound idea. The target knows best. Instead of making the little assistant model guess what the big model is thinking, DFlash just tells it. It lets the little guy in on the secret. This really breaks down the two massive changes. First, DFlash uses a drafter that can guess an entire block of text all at once, in parallel. Game changer. But the second part, that's the real magic. It creates what you can only really describe as a mind meld between the small model and the big model. So how does this mind meld actually work? It's a technique called key value injection. What it really means is DFlash literally takes the internal thoughts, the hidden states, from the big smart model and injects them directly into every single layer of the small drafter. It's like the big model is passing down its internal notes, highlighting what's important, the key, and what it means, the value, so the drafter knows exactly what to guess. And does it work? Oh yeah, the numbers don't lie. The drafter's guesses become so incredibly accurate that the main model accepts, on average, almost 6.5 tokens every single time. That's nearly double what the old method could do. It's this 1-2 punch of guessing faster and guessing better that creates this insane speed up. So, the theory is solid, it sounds amazing on paper, but what happens when the rubber meets the road? Let's get into the hard data and look at the actual benchmarks. First up, let's throw some really tough stuff at it. Complex reasoning tasks like math problems and writing code. These are a perfect test because the AI has to generate these long, super structured answers, which is where that old slowness really hurt. And wow, the results are just staggering. Look at this. The previous best, Eagle 3, gave you about a 2x speedup. Pretty good, right? Well, DFlash comes in and clocks a 6 times speedup on math problems and over 5.5 times on code. That's not just an improvement, that's a whole different league. But it's not a silver bullet for absolutely everything. What about something a lot more unpredictable, like just having a normal conversation with a chatbot? Right, so in this case, the speedup isn't quite as dramatic, but it's still a huge improvement. For these conversational tasks, DFlash is about 2.75 times faster compared to the old system, which was under 2x. So why the difference? Well, open-ended chat is just harder to predict, so it's tougher for the drafter to make those long, perfect guesses. Still, a nearly 3x lossless speedup, I'll absolutely take it.
The tech is obviously incredible. The numbers are amazing. But what does this actually mean for you? For developers, for companies trying to use this stuff in the real world? Let's talk about the practical side of DFlash.
And it's really important to be realistic here. This isn't something you can just drop into your project tomorrow. For one, it's locked into the NVIDIA ecosystem, so no other hardware for now. You also need to train a special custom drafter for every single LLM you want to use, and that's a big deal. And maybe most critically for big services, the more people using the model at once, the less speedup you actually get. This scorecard really tells the whole story. For technical innovation and raw speed, 5 stars. Absolutely. No question, it's a paradigm shift. But current usability? Only 1 star, because you need that very specific infrastructure. Still, its feature relevance is off the charts. This is a clear preview of how AI is going to be served in the future. So our final verdict is pretty clear. Watch and wait. Look, DFlash is a monumental breakthrough, no doubt about it. But given the current hardware and ecosystem requirements, it's a technology most folks should probably keep a very close eye on rather than jumping in right now. The big exception, of course, is if you're already self-hosting models on your own NVIDIA hardware. But here is the bottom line, the real takeaway. It all comes down to cost. A 5 to 6 times boost in efficiency means you can handle 5 to 6 times more requests on the exact same hardware. That could translate to an 80% reduction in AI serving costs. And that's a number that makes everyone in the AI world sit up and pay very close attention. And that leaves us with this one big, exciting question. A 5-fold increase in AI efficiency isn't science fiction anymore. It's here today. The question is no longer if we can do more with AI, but what amazing, previously impossible things are we all going to build with this newfound power?